Welcome to this test-driven development course in C#. My name is Yannick and I'm your instructor for this course. During this video, you will learn all the basic information and practices about test-driven development in C#. This YouTube course covers 2 out of 5 chapters from our complete C# TDD course. If you directly want to go ahead and watch the full course instead, including personal programming tasks and handouts for all the important information, you can find the link to our all-access subscription, which includes the C# TDD course, in the description below. You can start your free trial right away and watch the complete C# TDD course over here. You will get instant access to all of our existing courses and all future ones too. Now, before we start with the main content of this video, I want to give you a challenge. If we reach 1,500 likes after uploading this video in 3 months, we will create a new course about advanced C# topics, such as asynchronous programming, queues and much more. If you want to decide what's in that course, write it now down in the comments below. So if you wish for a specific topic in C# and you want to see it in that course, write it down into the comments now. Give the video a thumb up, and if you're not a subscriber already, you should definitely check that subscribe button because you don't want to miss any of our complete programming courses for sure. Awesome, so now let's get started with C# and test-driven development.
Welcome to our test-driven development course. That you have joined us means that you are serious about your future career in software engineering. So I have to say congratulations on starting the course and hope for the best for your future career in the software engineering industry. During this course, you will learn the differences between automated and manual testing. You will learn to set up test projects, and we will discuss various techniques during this course, such as given, when, then and red-green refactor patterns, test trustworthiness and devil's advocate game, parameterized testing, discovering alternative path after writing a test, conforming to TDD laws, and testing the application layer. We start by reviewing how we manually test our applications. You will learn the difference between manual and automated testing. Also, we will start right away and create a project and write the first test. And at the end of the first chapter, you will know what test-first development is and how to write good assertion messages. And finally, we will install some libraries we use to write unit tests. If you Google what test-driven development is, you will see lots of short descriptions, but you can actually not get anything from them. The definitions are not wrong, and you're also smart enough, but the problem is that TDD is like nothing else you have learned about software development before, and it's not introducible with only a couple of simple sentences. So rather than starting with a theoretical introduction, I will walk you through a practical introduction to TDD. So let's start with something familiar. What is manual testing? How do we test our application? Well, first of all, we write some basic code. Then run it and test if it works as expected. Then we may find some bugs. All the requirements may change, so we finally have to change the code, run it again, and so on. The problem is that you may break some working features every time you modify the code. And to make sure that the program still works as expected, you have to test all affectable features each time you change the code. And that's very time consuming, right? And undependable. Each change you make to code in that situation makes you less confident. The less confidence causes worse development experience and less productivity. And on the other hand, the time you need to spend testing grows exponentially, and each time you run the application you might forget to test something important. Now you might ask if there is a better way, and of course there is. And that's why we are here, right? Rather than testing everything manually by each time you modify the code, you can write some code to test the most critical parts of your program, so that every time you change your code, you simply run the code that tests it. And that's much faster and way more reliable. No worries, it's simple. I will describe it again using an example right now. Imagine an application that sums 2 numbers. Well, how do you test it? After you run it, you input 2 numbers and click the sum button. What should you see as the sum of 2 and 2? Well, it's obvious, 4 for sure. That you know what you should see as the result, you can write some code to test it instead of testing it manually. Let's take a look at the sum function, which handles the logic behind this user interface regardless of its I/O technology. Let's write some code that tests the sum function behind the user interface. Forget about UI technology just for now. This is the core logic of the application. You want to test this. Let's write some code to check if the sum function works as expected. This is the same test as the one we did manually. And it's automated. I can run it every time I change the sum function, and it throws an exception as soon as I break this behavior. Let's move the test code to a method. This is called a test method. We call the sum method the system under test in this context. So test methods test whether the system under test satisfies an expectation successfully or not. And we expect the sum of 2 and 2 to be 4. You can see the name of the method here, explaining exactly what should be tested, right? So just forget about all the complex terms. We have a simple test method, which tells us exactly what we want to test inside of the logic of that method. And then we simply call our sum method, passing in the parameters and check for the result, and automatically calling this test method an automated test. So here we are in Visual Studio 2022, and I will now create a new project, and you should do that too if you are following along with that course. And I really think that you should do that. So don't only sit there and watch the video. Please go ahead and open up Visual Studio and create a project and follow along in a more practical way. Our goal at Tutorials EU is to provide you the very best learning experience, and that for sure also needs some actions from your side. So you will need to get active too. Now let's create a new project, and we are using a testing framework which is called XUnit. So simply search for XUnit and create an XUnit test project, and that one got originally also created from the author of NUnit. You might know that testing framework, or maybe you already heard the term. However, XUnit also runs on .NET Core. You can see that here on .NET Core, Windows, Linux and Mac OS. So simply go ahead, select that one, click on next, and let's call it calculator. Now hit next and select .NET 6 and hit create. Let's write the sum function which we have just discovered and defined in one of the last videos. So simply write down here and sum. So we create a method and we got int left and integer for right side. Now let's simply return left right, AI taking place here. So in fact we simply created a method of return type integer which takes two parameters. The first one is called left, the second one is called right. And in the end, we just sum them up, right, and return the actual result of it. So right now, we have simply created a C# default method. Now take a look at the C# script that we have here. We have a class called UnitTest1, and here we have an attribute which is called fact. So if we now want to go ahead and automatically test our new sum method here, the only thing that we have to do to make that really quick is to create an if statement. Let's say if sum of 2 and 2 is unequals to 4, then we want to go ahead and throw in a new exception. A system exception, that's fine in case we haven't included the namespace, but I want to do that because I want to keep the code as short as possible. So let's go using system. So this one is no longer used. Okay, so here we have a test method, which is indicated by the fact attribute. We will get to that just in a second. And inside here, we call our sum method and we check if the result 2 and 2 is not 4, but it should be. And in every other case, so anything is wrong with our method, we will throw an exception. Because the only thing that this method here has to do is to sum two numbers, and 2 and 2 should be 4. And if it's not 4, the algorithm inside here would be wrong. Right now, it's just a very simple algorithm, right? It's just addition of two numbers. However, we also need to make sure that our testing condition is right. So sum 2 and 3, right, that will be a wrong testing condition because our defined statement is wrong at all. So always make sure that your testing condition matches the actual result that you are expecting. Let's save it like this. Okay, now I want to show you how you can run an actual test, because right now you might think, okay, I can test it when I hit the green play button or start button at the top side of the screen, but that's wrong. You can start the test and you can run the code test by right-clicking on the method and simply hit Run Tests. Now, let's do that. A new Test Explorer window will appear and you can see that the tests are now processing. Let's give it just a second to get everything done. And you can see the result is that our calculator, let's open it up, unit test class, test1. This is exactly the name of the test method here, right? The naming, we will change that just in a second, but that's the method that got tested and it actually succeeded. So this was a successful test. You can see that here, 1 passed. So if we do this like sum 2 and 3, right? So this would be wrong. Let's simply save it and rerun the test. Here you can see run all tests in view and simply run. Let me hit run again. You can see it failed because, well, we said that it failed. 2 and 3 is not 4, so we throw an exception, and throwing an exception from a testing method is a failure. So let's simply correct that again, 2 and 2, let's set it again. So this is how you can create a test method and how you can actually start it. And as you have seen, we have 2 outcomes or 2 possible outcomes, which is actually passed or failed. Congratulations, you just have created your very first test method. Now let's get rid of this bad naming convention here. Let's refactor our project in a very professional way, how you would do it as a professional software engineer. Okay, so now pay attention because that's very important. We have just created a new project and that project is only for test scenarios. Here we have our calculator method, right? If we would have a calculator, the calculator should have that functional method, right? And not our test project. So this is called a domain layer. So we will now create a real calculator project and bring that method into there and then reference it instead of having the functional calculator code inside of the test project, right? So what we do is you right click on your solution, very important, not on your project, and we add a new project to our solution. And this is what you will see in a lot of real world applications. You have a test project and you have another project which actually contains the algorithms and functional code. So here we search next up for a class library. Simply write down class library. There we go. A project for creating a class library that targets .NET or .NET Standard. So select that one and hit next. Let me call that domain. Domain always means that inside of the domain layer, you can find the actual, well, logic behind an application. So if we have a calculator, we would find the mathematical operation handling inside of the domain layer. Now let's hit next, select .NET 6 again, and let's hit create. So next up, we will rename class 1 here. So right click rename. So this is very important because we want to update all references. And let's call it calculator. Let's hit apply, and now every reference got changed. So never go ahead and simply write down a different name, always right click and update all the references by right clicking and setting rename. Just as I said, move to unit test 1 and here we got our actual logical code. We have a method here which should be inside of the calculator and not inside of the testing project. So let's take that method here. I will just select it and hit Ctrl X to cut it out. Now I got that copied, right? Save it and bring it inside the calculator class, because here we should have the logical code for the calculator, right? So if you see it from that side, it totally makes sense, right? Now let's switch over to our unit test. You can see that the sum method for sure is not available. Let's add a reference to our test project. So on the right side, make a right click on the calculator project. This is our testing project. You can see that indicated by that small flask sign here. So right click on it, hit add, and then add a project reference. And for sure we want to add our domain project, which is actually the calculator. So hit OK. Awesome. So we now wired them both together, switch over to the calculator and make that sum method public so that we can access it. Now inside of the testing project, start using domain. And inside of domain, we for sure got our calculator, which has the sum method. Now, if you are familiar with C#, you can tell that we for sure cannot only call the sum method like this we have to create an instance of the calculator, right? So let's create a new object, var calculator equals to new calculator. And that, well, you have seen that just right now. The reference is for sure wrong, because if we say calculator, well, if we do it like this, it will try to create an instance like that of our namespace, which is for sure not working. So our namespace, let's just rename it. That's it. Right click, rename, and call the calculator test. Now hit apply. So the namespace got now adjusted to calculator test. And we can now, instead of calculator test here, say new calculator, right? New calculator. There we go. And now it's referencing for sure the correct class. So instead of calling sum here directly, we now say calculator dot sum, and that will work. Okay, so basic C# going on here. Just to make that clear, we have two projects. One is the domain, which actually contains the calculator class, and the second one is our calculator test project, which is just like a not so nice set name. Here we now adjusted the calculator test namespace, so we give it a new name, which well avoids that sort of double reference. So let's also rename our test project. So right click on calculator and let's rename it. Let's call it calculator test. Awesome. So in that way, the namings are clear now. Instead of our unit test project, again, right click the test one method. We will also rename that just in a second and hit run tests. Always make sure in test-driven development that you for sure run your test if you change something inside of your code. So here we added a new project, we added a new class, we added references. It's a very good approach to now go ahead and run the actual test, right? So you can see it passed, so our implementation is working fine, even though it might get a little bit complicated, right? So we changed something here, we added something there, we wired some stuff together, we needed to resolve some reference issues. However, in the end, we simply run a test and see everything works fine. Hey, I hope you enjoy this course. Don't forget to start your free trial of our All Access Pass to get instant access to the complete TDD course. In addition to that, you will also get access to all of our other existing courses and even all future ones. So if you take learning C# serious, you should definitely check it out. We got tons of C# courses covered there. We got TDD, ASP.NET Core, C# Productivity, the 35-hour-long C# Masterclass, and also a lot of Unity courses too. And we are always working on new courses. If you join the All Access Pass now, you will get handouts and programming exercises for this TDD course, so don't miss that. Start your free trial now and I will see you over there. Great, so now just to make that clear, right now we have two projects. One for testing and the second one is actually the domain layer, which contains all of the functional stuff from the calculator. And this is how you really should build up professional applications. Now, in order to make that complete, because as I said, we want to focus on real world applications here, we are going to create even another project, because that's how professional software is built out there in the industry. So right click on your solution and add a new project. And this time we will add an ASP.NET Core Web API. You can see that here, ASP.NET Core Web API. If you have never ever touched anything with ASP.NET Core and C#, you are definitely missing out, right? So go ahead and check out our ASP.NET Core 6 course on YouTube, or you can find the complete course inside of our full access subscription from tutorials to you, right? It contains so much content. And if you are interested in C#, right? And if you really work as a C# developer, you need to learn ASP.NET Core. I can definitely promise that. So let's go ahead. ASP.NET Core Web API. We select that one and hit on next. Now let's simply call it Web. Let's hit next again. Again, we select .NET 6, configure for HTTPS, no authentication, and we don't need Docker right now. So simply hit create. Now just to make that very, very easy, what is a Web API? Well, just think about that. What we will do is we will bring our calculator online. So later on, everyone can call our calculator methods. That's what we are doing, right? So we're offering an application interface on the web where someone else can send requests to our calculator, right? From a theoretical part, we will not host the application here because we are really just interested in how to build such applications, not how to host them right now, because we are focusing on test-driven development, right? So don't forget that. Now, the first thing that we have to do, we need to add a reference all of the domain library to the web project. So I will switch to the web project. I got that right here, right? It's indicated by that nice internet logo or internet icon here. And again, we do a right click and add a project reference. There we go. And we want to add the domain layer, because just think about that. Now, pay attention. Our web interface, which is actually for the actual user, and that interface calls the actual functional stuff, which is inside the domain. Now, our web project does not need any reference to testing, because only test and domain should be connected. So test and domain are connected, and domain and web project are connected. Never forget, domain is our functional code. So let's go ahead and add the domain reference, because if someone wants to call a sum method on the calculator from web, our web project needs to know how to call the sum method, or what even that is, right? Now you can see that we have inside of the web project a weather forecast here and the weather forecast controller inside of the controllers folder. So this is called an API controller. Let's open that up, and you can see it's indicated here by two comments, which is API controller and the actual route. So if I go ahead and start the application, I will be able to access code from inside here, methods and all of that, by going to localhost, colon, and then enter a port like 1234, and then / weather forecast, and then for example / weather forecast, and that will result in that method here getting called. So I will just get some random weather information. Okay, we will not dive deeper into that. Let's just adjust it so that it's matching our scenario. So right click on the weather forecast controller, hit rename, and write down calculate controller. Let me hit apply. You can see calculate controller, and it automatically also renamed the file. So it's now called calculatecontroller.cs. That's awesome. Let's save it like this. Now delete the weather forecast.cs. We also don't need that one. And now switch back to the calculator controller, and we can delete the complete code from that get method here, and we will switch it over from returning an IE numerable. We changed that, and this method or action will return an integer, right? Call it get, just like that. And if someone is actually calling that from the web, he wants to provide two numbers, right? So please sum up 5 and 10, for example. So again, we will build a structure similar to our actual functional code. Let's just set the path here in a different way. As I said, please don't care too much about what we're doing right now. I really want to give you, well, a real world scenario on how an application would be set up, but it's right now not related to any testing, but you will see everything just in a second. So if you follow along, just do it exactly like this. Take your time right now and write it down like that. This here is just a route that we are defining. And there I made a mistake, should look like this. And now what we do, and that's the interesting part, or the important part, we now add our domain here. So we call the calculator.sum. So let's go and start using domain, because we added the project reference. So if you haven't done that, you will not be able to use domain. Now let's create a new calculator. So var calculator equals to new calculator. And we simply return calculator.sum. And for sure, we will provide left and right, which we are receiving from the action here. So this is a method, but it's called action because it's an API controller. So let me just get that clear. If we host this application, this web project, for example, anyone could call this method here. So he will provide left and right by writing down like any URL in the browser /add/5/10. 5 will then be here left and 10 will be right then. And then we call our calculator and sum it up and return it as a response for the user. So in the best scenario, you have some prior knowledge about web development, and a lot of people have it. So I'm pretty sure that you understand what I'm talking about. And really, if you have no idea of web development in general, you really have to take care about that, because most of the applications out there are built for any web scenario. So don't worry about that too much. Go ahead and watch this course about TDD. That's all good. But afterwards, you should go ahead and learn web development for C#, ASP. And we really got a lot of ASP.NET content. So we got you covered. Perfect. Let's save it like this and just see that we can go to the calculator.cs. And inside here, we got our functional code, right? And we can now simply change that if we think our logic from that sum method should be different. Obviously right now it's correct, right? But let's just assume you need to change it. You can simply change it here and it gets referenced everywhere. In the testing project and also in the web project. So you're changing it once at one position and all references are updated for sure. As I said, not all function bodies are as simple as the sum function right here. Since we are calling the plus here in the sum function, we don't seem to break something by mistake, right? And that's because I wanted the first example to be very simple to understand. Now let's replace the plus sign here with the minus sign as we have done it before. And let's simply run the test. So right click and again run test. And we have done that before. So hit run and you can see that the test failed. So now what if we write down an application which has a functional method just like this one, but it's not that easy to write it down so that you end up by resulting in a failed test. And this is why there is an approach which is called test first. And we will take care about that right now. So just to make that clear, we will for sure replace it with a plus sign here again so that everything is working. But now we focus on test first approach. So let's move on and talk about that. We just wrote the sum function and then we wrote the test code. So the test we just wrote was a simple example of an automated test. However, we didn't follow the test-driven development approach. Because based on the TDD approach, you must write the test before writing the actual production code. So in our next step, I will show you what it means to write tests before having any production code. And we will discuss the reason for this later on. So let's rewrite our sum function using the test first approach. So that might feel a little bit weird now, but we will now remove the calculator because as I said, the TDD approach is writing tests before writing the production or the functional code. So let's really do that, okay? Don't feel sad about that calculator because he will come back later on again. So simply go ahead and delete the calculator project. Now inside of our calculate controller, let me just close that test explorer here, we are for sure referencing it. However, let's remove the using domain here and for our calculator, new calculator, let's remove the code here and simply throw new not implemented exception, right? So this is also very important. If you're writing tests, you might stumble across moments where you want to throw a not implemented exception. Now finally, go to the unit test1 class that we have right here and simply keep that empty. So right now we have a web API project, which is like doing nothing. And we have a unit test project, which is also clean again. And we have a domain layer, which does not contain any element anymore. You can see that right here. So now we are good to go to first of all, think about our project, then write the test and then write the production code. Okay, so don't forget that. This is the approach right now. The first question that we should ask ourselves is, what do I want? And basically, this is really something you want to ask yourself as often as possible as a developer, and many people are not doing it, but you should do it. Always ask yourself, what do I even want? What should my program do? In that specific scenario, we want a sum function. So our next step is to simply think about what our sum function should be able to do. Well, in that scenario, you might end up with something in your head like, okay, the sum of 2 and 2 should be 4, right? So as I said, it's a very easy scenario, but in TDD, it's more about the actual workflow, about the actual approach, not about the really specific algorithm. So let's remove our, well, automatically generated test here. You could also rename it, but I want to write it from scratch. So in my head, I got that, okay, my sum, you can also write that down for sure, or write a comment. My sum function works like this. If I add 2 and 2, the result should be 4. So now what I do is I write a test method and write down here an attribute called fact. Next up, I write down public void. And now I really name the method, the test method, as what I have just said. So sum of 2 and 2 should be 4. All right, so this is super easy to read. So the method or the code block inside of that test method should really be exactly that. We will now add 2 and 2 and the result should be 4. So this is our test scenario. Now let's write that down. Var result equals to sum. And now it becomes a little bit weird because we are writing down code which is not existing yet, right? And that might feel wrong, but it's totally fine because we will just solve the error step by step, and that's totally fine and part of the actual approach. So right now we are writing down a future version of a sum method which is taking 2 parameters and the result should be 4. So let's remove those red lines and make the build pass. Let's again write down a sum method here based on that information. So that's very important. First of all, you think about a scenario, you create that test method including the name, you write the actual test code, and then you just get step by step through the red underlines, through the errors. So right now we need to create a sum method. So we go ahead and create a sum method. And in that case, you have written down the test even before you have written down the logic, because right now I'm writing down the actual code block. Let's throw new not implemented exception. There we go. So even right now, there's still no logical code, but actually we removed every red line and our code is working again. So at the very top, I can see I have still that domain namespace integrated. I will remove it, but now it's working, right? So we have defined the test and then we added the sum method because we needed to in order to let the project compile. And then we don't even care about the actual logic of it. Let's just think about what should the sum function return. It should return 4. So let's throw a new exception if it does not. If result ain't 4, so if it's not 4, we want to throw a new exception. There we go. Very easy to follow along. Now let's start the test, and the test has to start so our project can compile, but the test has to fail because we have no actual logic inside of our sum method, and you can see that it failed, and that's totally fine right now. Now let's follow along on that. You should know that it's totally fine if it fails because it helps you to write actual good code. So it's not like you write down everything and it works straight out of the box, right? You really follow along on those failed tests or error references. So let's try to make the test pass because that's what we are aiming for. We should really follow the error guide. So read the errors and fix them. Take a look here in the error list. So open up the drop down here. Sum of 2 and 2 should be 4. And you can see some information here. You could for sure also attach that window anywhere. You don't have to have it like a pop-up as I do. Go ahead and attach it at the very bottom at Visual Studio, but that's easier for the videos here. So system not implemented exception, the method or operation is not implemented. Totally makes sense, right? Because we are throwing a not implemented exception. So that tells us that we now should go ahead and implement some logic here. Let's do that. The algorithm here is pretty simple as we already have discovered. Return left plus right. There we go. So again, we are creating the sum function as a part of our domain model. So we should move it to the domain library to enable the web application to call it again, right? However, we will do that just in a second. Let's test again. So hit run, and this time you can see everything is working here fine. Great, so that's very cool. However, as I already explained in the test project, we have no logical code included, or we should not, only test scenarios. So let's take that sum method and bring it into our domain project again. So inside of our domain project, let's create a new class and let's call it calculator. Now inside of that calculator, we will bring that sum method. So let me just copy it and remove it. Go to the calculator inside of domain layer again and paste it here. Now again, we need to make it public so that we can call it later on. So that's great. Let's go to the unit test again here. And you can see that we cannot call the sum method here because we need to create a calculator. So let's go to our calculator.cs and change that from being internal to public for sure, so that we can create instances. Now switch over to the unit test again And now we can create a new calculator. So var calculator equals to new calculator. So let's go ahead, start using domain again. And inside that namespace, we have the calculator. So new calculator, there we go. Now we have the instance of the calculator object, and we can simply call calculator.sum. Awesome. So now we finished the implementation. Everything is just as we needed. We have the test, no logical code here, only testing scenario. And we have the domain layer, which again, there we go, which again contains the actual functional code. And we have our web API, which we need to finish up now again. So what we can simply do is we can simply return new, and we go ahead and using domain again here, right? So we call new calculator dot sum, and we sum up left and right. So now we got everything just as it was before, right? There is no difference at all. But the approach was completely different. This time we really thought about what do I want to have, then we built out the test, and then we built out the method, then we added the class, then we brought that method into the class, and then we wired everything up together again to make everything working. And this is the typical TDD test first approach. To make sure that everything is running, again go to unit test, right click, and run test. Awesome. So as you can see, everything has passed, so everything is working fine right now. When a test fails, the error message should explicitly indicate what went wrong. Because imagine that you have hundreds of tests in your application, and this is absolutely common practice. So a subset of these tests is failing due to the recent modifications of the code. You should be able to quickly figure out the reason, right? So now for a quick test, let's simply go ahead and return 5 from our calculator sum method. So go into the calculator, here we got the sum method. Let's just comment that out and let's simply return 5, which is obviously wrong, right? Because first of all, we don't use left and right, but however, when we go to the test, you can see that we expect the result to be 4, and if not, we throw an exception. And since sum is now always returning 5, it doesn't really matter what we enter here. So in fact, our test will fail. Let's right click, run tests again. Let's open up everything what we got right here until we come to the actual testing method. And you can see that the message right here is system exception of type system exception was thrown. And this is because if we run into an issue, we throw an exception here, which is absolutely not really saying us anything than, well, there is an error, but we don't provide any information, right? In fact, it tells us nothing about what went wrong and the reason that the test failed. So let's actually throw a more useful error message. Inside of the parameter here, we pass in a formatted string. Let's say the sum. We can hardcode this because that's our testing scenario. It's also hardcoded in the method, right? So that's absolutely no problem. The sum 2 was expected to be 4, but it's, and then pass in the result. So this is some useful information actually, which helps us to fix problems in our application depending on whatever we return or we get as a result from our test. So let's rerun the test just one time. And now you can see system exception, the sum 2 was expected to be 4, but it's 5. So right now we have a really nice, well, exception message, which also tells us about the actual result and what we are expecting. So this is nice, and it directly indicates that the calculation of 2 and 2 here, anything there is wrong. So our testing scenario would be 2 and 2 is 4, and the outcome was 5. So anything here was absolutely programmed in the wrong way. However, we don't need to use 2 and 2 should be 4. We could also go ahead and say 10 plus 10 should be 20, or 1000 plus 500 should be 1500, right? So everything here which adds 2 numbers would work fine. But you have to think about one specific test scenario. Just think about it. What could a user enter and what would be a valid result? So a user types in 2 and 2 and the result should be 4. That's a valid testing scenario. However, the assertion message, that's the message we're getting right here from the test, is specific and unique now. So I understand the exact reason for the test failure as soon as I look at it. And now we are able to fix it. So we can see that this sum method is wrong. Let's go into it and we can see that we are returning 5 here and that's not correct. So we directly come to the right point. Let's bring in the correct logic here, right? So we can save it. And again, if we changed something, you also want to pay attention on that here, right? So you can see it's not passing, but we want to make that pass. So let's run the test again after fixing the issue or after we think that we fixed the issue. And you can see that when you start or restart the test, everything is working now and that the test has passed successfully. Awesome. Now there's still a lot to improve and we really want to teach you the best way. So inside of the unit test, you can see that if statement here. And well, those if statements make the code base look complicated. So what we do next is we install a library to remove the if statement from our test and clean up the test code. And for that, we will use the so-called Fluent Assertions. So let's dive into that. Let's install a package for our project, which is called Fluent Assertions. So let's go ahead to Tools, NuGet Package Manager, Manage NuGet Packages for Solution. And on the left side, click on Browse and search for Fluent Assertions. So you get that here. You can see 164 million downloads. So yeah, it's getting used a lot and you want to use that too. So let's install that for our testing project. And our testing project is the calculated test, right? So because, well, we will use those Fluent Assertions inside of our tests. So we only need that for the testing project. Simply hit install. And if there are any licenses to agree on, do that. Now, once that's done, you can close the Solution NuGet Explorer here. Go to the unit test again. Let me just get that view right and start using Fluent Assertions. So, and as I said in the earlier video, we want to get rid of the if statement here because that makes our code look a little bit messy. And what you will see now is super cool. So let's just get rid of the complete if statement here. And what we can simply do is we can say result.should.be 4. And this is so much cooler and shorter and easier to read than the if statement. So our result should be 4. Well, how much easier could it be, right? So it's absolutely human readable in the very best possible way. But what error message do I see if the test fails? Let's switch over to our calculator again. And one more time, we will return 5. So let's save it, go to the unit test, right click and start our test. Always make sure to actually really run it. Well, you can see that we have now also a nice message. Expected result to be 4, but found 5. So the message is not as clear as the one that we have wrote. But however, look at the test method's name. It's sum of 2 and 2 should be 4. And the error message is expected result to be 4, but found 5. So the method name and the error message together will give us enough information to quickly understand the problem and fix it, right? So taking the message and the actual name of the method will give us enough information. So we can still assume that something inside of the sum method here logically is wrong. Again, let's fix it. Go to the calculator, remove that line of code, bring in the original correct code, save it, rerun the test. Now let's clean up the test code and remove the unnecessary noise to make it as readable as possible. Let me just close the test explorer here and let's shorten that up. So instead of using the curly braces, we can simply go ahead and say goes to new calculator, and that calculator calls dot sum 2 and 2. This results in an integer, and we say that integer should dot be 4. Okay, so I guess you cannot even simplify it more than that. From a functional perspective, it's exactly the same thing for sure, but it's easier to read and even shorter. Now let's keep this practice. Go to the calculator, to the functional side. Let's do exactly the same thing. Remove the curly braces, goes to left plus right. It's returning it automatically. There we go. It's easy as that. However, this is not really related to TDD, but well, software designing in general. Finally, move over to the unit test and let's get rid of that really unmatching class name. Instead of calling it unit test 1, right click, rename it to calculator tests. There we go. That's definitely looking way better now. Awesome. So let's just recap this. Now allow me to bring you an example. However, first of all, thanks a lot for Jonathan Dubon for that nice image. We grabbed it from Unsplash. So we are mentioning the creator here. Thanks again. However, guitar tuners are devices that help guitarists to tune their guitars, right? Guitarists should adjust the knobs to get the sound the tuner expects. You can think of a tuner as a test and the guitar sound's tunefulness as the production code. Before the guitar is tuned, the tuner knows how the notes should sound. So the test knows how the actual result should look like. Then the guitarists adjust the knobs based on the tuner's lead until the guitar sound satisfies the tuner's expectations. So you got the tests, which know how the result should look like, and you adjust your source code, your actual functional code, to match the test's expectations. So this analogy demonstrates how the test-first development works. Before you write any production code, you first write a code that specifies how the production code is expected to work. The first rule of TDD is to write production code only to pass a failing test. Writing tests before writing production code is called the test-first approach. And in chapter 1, we have now finally reviewed the manual testing process. We created a test project and wrote the first automated test. Then we moved on and removed the code and everything from scratch based on the test-first development. We talked about writing good assertion messages and wrote an excellent assertion message for the test we had written. Finally, we installed the Fluent Assertions library and used it in our tests. So, congratulations on watching the first chapter completely. Now you can write an automated test and it's your turn to take action. We went through a practical introduction to TDD now, and in the next chapter we will continue with some theories along with some real-world examples. And if you are not watching this course from our all access subscription, so if you're, for example, right now on YouTube, you might want to go ahead into the all access subscription so that you get personal tasks. So we got some tasks and exercises prepared for you and you can grab them there. Also, we got some nice handouts so that you got all the information really in a nice format. And you can sign up for that all access 7 days for free and start right away. So if you're already in the all access subscription, good job. If you are not, go ahead and sign up right now. Let's get started with chapter 2 of test-driven development in C#. In the last chapter, we started with a practical introduction to TDD, and now we are going to start with some more theories and see them in practice. At the end of chapter 2's presentation, you will have learned why writing tests first is important, what are test preconditions, and the red-green refactor pattern. Software development is building solutions for some of the stakeholders' problems. To build high-quality software, you should think before starting to write any code. You should understand the problem in depth, then design a solution out of it. Before starting to implement the body of a function, for example, you should know which parameters clients should pass to it and what the consequences of calling it is. In other words, you should know what you expect the functions to do, not how the function does it. TDD experts think and make the expected requirements as explicit as possible. Then they start implementing the production code until the production code meets the actual expected requirements. Well, it sounds confusing? No worries, we will see what it means. Imagine that you want to write a division function. Before starting to write the body of the function, you should consider what parameters client should pass to it and what the division function would return to the clients in turn. For example, 4 divided by 2 should be 2. This is a behavior that all clients expect from the div function. This expectation is a test scenario. Whenever you want to write a production code, you should think about 3 things. What is the input of the code you want to implement? What is the outcome? And which function method or class should receive the input and conclude the output? Imagine that you want to test if a car ignition works correctly. When you start the ignition, you should hear the car engine sound. The input is starting the ignition, and the outcome is the engine sound. Is the test scenario complete? What if the car doesn't start because it has no gas? Does that mean that the ignition does not work? Obviously not. To test the ignition, the car should have gas. We should always fill the tank before trying the ignition. Filling the tank is a precondition in that scenario. A precondition is a part of the test scenario. Any test scenario can have 0 to multiple preconditions. Some test scenarios may have no preconditions, but every test scenario should have an input, a system on the test, and an outcome. So let's continue with a real-world example because that's most of the time way easier to understand. Imagine a flight booking application like we have built it in our 21-day ASP.NET Core and ASP course. When I book a flight, the number of remaining seats should be reduced. As a passenger, how many seats should remain bookable for the flight if I book 1 seat? Well, it depends on how many seats the flight had when I was booking it. So something is missing from this test scenario. It requires a precondition. We need to define the initial seat capacity of the flight before booking it to be able to check if the book method reduces the number of seats of the flight object correctly. So now we have a complete scenario. So let's get our hands dirty and implement it directly inside of a new project. Great, so now let's create a new project and we will call that flight because we will use, well, exactly those scenarios that we had in the last presentation. So we will take care about booking flights. Let's create a new XUnit test project here and I will simply call it flight. You can for sure also call it flight test or whatever you like, right? So this will be our testing project because we are, well, using the XUnit test project template, right? So let's hit next and then again .NET 6 for now. That's fine because it's long term. And once the project got created, we will install the Fluent Assertion package again. So simply head over to Tools and then NuGet Package Manager, check Packages for Solution, move to Browse and search for Fluent Assertions. There we go. And again, as we have did it previously too, you're gonna install it for your testing project, which is flight now. And let's simply hit install. Awesome. Now that we have done, we have our next project set up for our upcoming tasks. Now let's bring those sticky posts that we have right here into our application using TDD. So first of all, we will create a new flight with a seat capacity of 3. Then we will book a flight and finally the result will be that the original flight will only have 2 seats remained, right? Because he started with 3, we booked 1, so he will have 2 left. So just keep that 3 steps in mind right now. So using the TDD approach, we would now create a flight, var flight equals to new flight, and we would write down with a seat capacity of 3. There we go. So we would pass that parameter here. The second post was booking, so flight.book. Then we would submit an email address, for example, so yannick@tutorials.com, it's not a real email address by the way. And we would book 1 seat, so 2 parameters here. Book the flight for Yannick and book 1 seat. And the third call would be flight.remaining number of seats should be, the result should be 2. So now This is the logic that we want to implement in our application, and you can see how this even helps building out, well, a real application, right? Even though we haven't included the core logic and the functionality, we have just sketched out how we imagine our software should look like from a code side, right? So now we will go through each error, create a flight, create a booking method, and finally take care of that remaining number of seats property here. And then everything will work as expected, and we have used the TDD approach. So I hope that it now gets clearer and clearer how and why you would use TDD. So you can see in the error log, in the error list at the bottom side of the screen, the first error. We will now go step by step through them. The first error is flight is a namespace, but it's used like a type. However, for flight he's referencing right now the namespace here, but we need to create a new class. Now we need to create a flight class, so let's create a new class library. Right click on your solution and add a new project, and again we add a class library. However, this time what we do to be even more professional, we create a domain library, but domain for .tests. So this is how we call our project. So everything that we now create for testing or regarding testing, for example that flight class, is not a production code right now. After testing and after finalizing everything, we will refactor this and build a stable production code from it, right? So if you are in the scenario where you're just writing down your new application or some new parts of your application, right? You are, well, in a development phase, right? And in a testing phase in that scenario here. And for this, we are now creating a flight class. And that flight class is for testing purposes right now. And if we decide that it's working fine and we want to keep it, we will build a production code from it and move it into a different production domain library. But for now, it's testing. So we keep it inside our test space. And this is why we create the test library for our domain layer. So let's hit next. .NET 6. Here we have our domain.test public class. Let's just rename it. Right click, rename. Let's call it flight. And inside there we have a public flight int seat capacity inside of the constructor, because that's the only way how we can really create a new flight and pass in the seat capacity, right? So we need to create a constructor and set it here. Great, so now in our unit test project, we can still not use it. First of all, we go into our flight test project, right click on it and add a new project reference and select our test domain here. Hit OK, that's fine. So now what we can do, let me just save that. So now what we can do is we can start using our domain.tests namespace. And there we got that flight here. So it's just conflicting with this namespace flight that we have right here. So we can for sure rename it, or instead of that, we could also go ahead and say, well, domain.tests.flight, right? So you can go either way. In that scenario, you for sure wouldn't need to start using the using directive here at the top side of the screen. It really depends on you. So you can also go ahead and rename the namespace right inside of the flight test project. And that's what I want to do, because I want to keep it a little bit simplified. So I will start using the domain tests and then right click and rename flight test like this, right? And you can see the reference was set wrong. That's why he used that, but we can just write down flight now. Awesome. So now we proceeded here and we can see some new errors popping up. Flight does not contain a definition for book. So what we do next, we switch over again and now we create a book method. Public void book string v1 string v2. So v1 and v2 for values, and afterwards we don't care about real logic here, so we just throw, there we go, new not implemented exception. Save it again. Switch over to unit test. You can see, all right, here's an issue, right? So he's trying to get a string, but he needs an integer. So you can see I need to change that, right? I mean, that was not related to TDD. It's just default error handling anyway. And the next thing that we have to do is to take care of that remaining number of seats property. So switch over to the flight again, and let's write down a property. We can write down prop public int. Oh, and if you use a shortcut, simply press tab. So let me do that again. I don't want to skip it. So you got prop, this is a shortcode, right? And then hit tab, and yeah, everything gets filled out. So public int, and then you can go through the fields using tab. So public int, let's go remaining number of seats, save, switch over to unit test project, and you could see, all right, that works fine. Now he's complaining about that should be because we don't use our Fluent Assertions. So start using Fluent Assertions. That's why we have implemented or included the NuGet package. And now everything is working fine. And we can start the test, right? So right click here, run test, give it some time to execute. You can see in the background, the application starts compiling. Yeah, and you can see that the test is failing. And that's totally fine right now. And we are only allowed to write production code to pass a failing test. And emphasize this as much as you can during this course, because it's the first rule of TDD, alright? We are only allowed to write production code to make a failing test pass. So right now, our test is failing and we need to fix this. And for that, we need to write production code. Okay, so if we check that here, take a look at the exception, not implemented exception. Let's switch over to our flight implementation here. Let me just bring that here. And let's get rid, or I will just close it. We can just remove the not implemented exception right now. So save it, go back again, and start running the test one more time. You can see it's still failing, but this time we got some more information from Fluent Assertion. So expected flight remaining number of seats to be 2, but found 0. So we have a difference of -2. Now let's see how we can fix this, because that's the actual implementation of the logic behind it, or the production code. So just for yourself, you can see this right here. This should be your solution, but just think about a possible implementation of how we can fix this failing test, right? So think about the core logic that we now have to implement in the flight to make the test pass now. To make the test pass. So in order to make this test pass, we for sure have to implement the logic. So we initialize a flight with 3 seats, then we remove 1 seat and book for Yannick right here. And then the result, so the remaining number of seats should be 2. Let's do this. So here we create a new instance inside of the constructor of the flight class. We say remaining number of seats is equals to the seat capacity, which we will provide in the call of the instantiation. So when we call the constructor, we say, hey, the flight has like 10 seats available. Remaining number of seats will be 10 then. And when we book a flight, and that's for sure, well, actually the decreasing part, we say remaining number of seats decreased by the second value, which is actually then the amount of booked seats. So that should be everything. Let's just talk about the red-green refactoring. So we started with translating some requirements to a failing test. Once we have a failing test, we should only think about how to pass it. So we write enough production code only to pass the test and not more. When the test passed, we shouldn't start writing the next test yet. We should think about how we can improve the existing code before we start to write the next test. So when a test passes, it's the time to refactor the code. Refactoring means restructuring code without alerting its external behavior. So the goal of refactoring is to improve the code design. Once we're done with refactoring, we can think about writing the next test again then. The red-green refactor is an essential process in test-driven development, and we will take a look at that refactoring part right now. We will start with the red-green refactoring by renaming that test method. So right-click on it, rename, let's call it booking reduces the number, you cannot see it, just a second, reduces the number of seats. So exactly what the test should do, right? Or test for. So booking, here there we go, reduces the number of seats. We book something and it reduces from 3 seats reduced by 1 to be resulting in 2. So always make sure to give your testing methods the best possible testing name. Next up, let's switch the name from being public class unit test 1 to right click, rename, flight specifications. Awesome. We can save that. Now we create a new domain class library again, but this time it's for production code. So right click on your solution and add a new project. Simply add a class library. Hit next, name it domain, and then hit next and create it. Now next up, we will move our flight class into our domain library because right now it's inside of domain.tests, but now we want to move it to production, so we move it to our domain project and not domain tests. So simply right click on flight. You can see quick actions and refactoring. You can also hit control dot, so hold the cursor above flight, control dot, and then you can see that we can move it to a namespace. So move to namespace, select the target namespace, which is domain, hit OK. You can now see everything here has changed, right? So everything got adjusted. And what we now do is we now simply select flight on the right side in the test project and bring it to domain. Now this creates a copy, but now we can delete the one from domain.test. There we go. Now in that order, if we check flight specifications, you can see that for sure he's trying to reference domain.test. We need to adjust that so that he uses the domain layer instead. So what we do now is we add a project reference. So right click on flight, add a project reference, and simply we can remove domain test if we don't need it for any other stuff later on. But for now I keep it checked, and add the domain reference too. So hit OK. Now we can start using domain and the new flight starts appearing here. We restructured the code but didn't change its behavior, right? So now we have to adjust 1 or 2 more things. Go into your flight class and change the name of the parameters of the book method. So because they are right now, well, not really telling us anything, let's call them passenger email. And for V2, we can also use right click and rename and set it to number of seats. Awesome. So now we are really using nice parameter names. Let's go into our test class, flight specifications, and right click and simply run the test, which should definitely pass again if we have refactored everything right. And now that the test passes, it actually tells us that we didn't change the behavior of the code. And this is exactly what we wanted to achieve because we only were interested in refactoring now. We first thought about a test scenario and visualized it using those sticky notes right here. Then we translated the sticky notes to the test. There's a general pattern for dividing steps of a test scenario. Some test scenarios have preconditions, as we talked about it already, right? Preparing the preconditions is the very first step. We call this step the given step. The given step in a test scenario was creating a new flight with a seat capacity of 3. Then there's the when step of what triggers the action. The when step in our scenario was to book a flight with a number of seats of 1. And the final step is the then step. The then step describes the expected outcome of the scenario. In our test scenario, the then step was that the number of remaining seats was expected to be 2. The flight class was our system under test, the subject which we were testing its behavior. Our test had 3 steps. We can read it like this. Given a new flight with a seat capacity of 3, when I book the flight of a seat, then the flight's number of remaining seats should be 2. The given when then format is just a pattern that makes it easy to communicate with business people and developers, right? When developers look at your code, they expect the code of given, when, and then steps to be explicitly separated from each other, as you can see it right here. The code with separated given when and then steps is easier to understand. We wrote each step in a separate line. The book method now looks like this. Is reducing the number of seats all the book method should really do? Well, obviously not. The book method should also prevent the passengers from overbooking the flight, and it should also remember all of the bookings that passengers make. What we implement in entities should happen in the business domain even if there is no software in between. The rules that business stakeholders expect from the operations in the business domain. In our flight booking example here, even if the stakeholders use pen and paper to book flights, they should avoid overbooking, right? Remember the booking and the reduced number of seats by each booking. So they finally store that piece of paper somewhere to keep track of everything. We store the entity, for example, in a database. But that doesn't mean we should copy the process from the existing manual system. So we should first analyze, design, and finally implement the software. Since covering analysis and design is outside this course scope for sure, let's implement the new scenarios, avoid overbooking flights, and remembering the bookings. Let's start with the avoiding overbooking scenario. As always, we don't want to jump into code. We want to think about the scenario without letting the compiler get in our way. So let's see what avoiding overbooking the flight means. It means that if the number of remaining seats is bigger than the number of passengers that the passenger wants to book, the flight entity should return an error instead of booking the flight. But how do we test this scenario? You should find a way to test this scenario. You should consider what parameters you need to pass the test flight entity and how to measure the outcome. We don't want to think about how to implement it yet. We want to think about how to test if the flight entity avoids overbooking at this point. Imagine that you want to see if your teammate has implemented the overbooking behavior without looking at the code base. So you run the application, pass some inputs, and check the output. To check if the flight entity avoids overbooking, you run the application and book 4 seats on a flight that only has 3 seats remaining and see if the application shows an overbooking error. So even if someone else implements the logic for it, you can write a simple test and check if the implementation of the code is actually working. Whenever you don't know how to test the required behavior, consider how you would check if an existing application already has this behavior. So you can use sticky notes, for example, like we did it right here, to visualize the steps. Once you discover the steps, we translate them to test code. So let's translate the avoiding overbook scenario together. And let's start with the test method's name. Test method's name should describe a flight's behavior. We can name this method, for example, flight avoids overbooking. And since the method is going to be in the flight specifications class, we can omit the flight from the test method's name. So the test method's name ends up avoid overbooking. It's time to translate the steps. Given a new flight with 3 seats capacity, when I book for 4 seats, then an error of type overbooking error should be returned. The email address does nothing in this scenario, but since we have to call the book method, we have to fill the parameter with something valid, right? Such parameters are called dummies. You might wonder why you should pass that parameter. The decision is made by the designer of the entity when he was designing the domain model. Domain modeling is outside of the scope of this course, because we are just talking about TDD, not software designing in general. So now let's again get our hands dirty and implement the avoid overbooking scenario in a TDD approach. So let's get started with creating our new test method for overbooking. Again, for sure for XUnit test methods, we have to use the attribute fact. Then we create a public void. And we call it avoids overbooking. There we go. And what we do is we create 3 statements. First one is given, followed by when, and then followed by then. So given, when, then. And this is just what we had in the last presentation. So what we create first is a flight, and we create a new flight, and we set the seat capacity to 3. Afterwards, we create an error here, flight dot, we book something for Yannick at tutorialcu.com, for example. And as discussed, we will book 4 seats. So we have 3 but we book 4, which would be an overbooking. So we expect to get an error here, right? For sure, this is not implemented yet. And then error dot should dot be of type, there you go, overbooking error. This is what we will have to create. Awesome. Now let's save this in that way so that we can now take a look at our error list and follow again through all the errors that we have and implement the logic behind it. Let's get started with the first error, cannot assign void to an implicitly typed variable. And we can fix this by changing the return type of the book method to be type object. So let's go into the book method. This is in our flight class, so we got that here, book, right? And we change it to be not void. Instead, it returns an object. And we don't always return an object, and this is where we make it nullable. So it can return an object, but it doesn't have to. So if there is an issue, we will return an error, that will be our object. And if everything goes well, we don't return anything else. So we add return null here, return null for now. That's fine. So that will fix the compilation error here. Let's add a new class to our domain layer. So in domain, we can add a new class, or we can simply take that class1.cs, which we have here. So let's right click and refactor it and change the name to overbooking error. So for that specific case, where we just have that overbook scenario, for this case, we will create a completely own class, right? So there are multiple ways how you can do that. You don't have to create a class, but we will do it like this. You can for sure also do something else, just create a new exception or whatever. Now, before we continue, let's first of all run our test to check if everything is working. So you see in our flight specifications that we don't have any errors anymore, and error should be of type overbooking error. So let's check, right click on it and run tests. You can now see that we have 2 tests here, which are inside of our test explorer. Let's see what happens. And you can see that avoids overbooking is not passing, expected error to be domain overbooking error, but found null. So what we need to do is we need to return an overbook error in the scenario where we have an actual overbooking, right? So let's implement the logic behind that. Inside of our flight book method here, we simply add a simple if statement. So if the number of seats that we want to book for a flight is bigger than the remaining number of seats that we have for the flight, we simply return a new overbook error. This is what we have to do, right? Pretty simple. Remember that we have that remaining number of seats for the flight, and we just get the information of how many seats we want to book for the flight. And if the number exceeds the remaining number of, well, available seats, we would have an overbook error. And for sure we return from here, so we would never reduce the remaining number of seats actually. Awesome, let's go ahead and run the test again and see if this now passes. Awesome, so you can see both of our tests are now working. We have the avoid overbooking, and booking reduces the number of seats. So both scenarios are working, and we use testing for this. So we don't have to actually start our application or our user interface, mobile app, web application or whatever, enter values and test it in that way. No, instead we have written C# tests which we can simply run with a single click and all at once. And that's really the absolute power of TDD. So we first of all discovered a test scenario, and then we translated it into test code. In my experience, the test that's easier to write is also easier to read. Remember that the first rule of TDD is to write production code only to pass a failing unit test. So we wrote the test code, we saw it failing, then we followed the errors and fixed them one by one until the test passed. And sometimes you want to test if something is possible or not. So you can write some exploratory code first to see if it's possible. Then throw it away and start over with discovering the scenario and writing the test first. Let's just sum this up again. Before starting to code, we should clearly specify what exactly we want to do. We create a mold using the scenario and pour the production code into it. From that point forth, the production code cannot behave differently than the initial expectations we forged into the mold. If there's only one thing you take out of this course, I want it to be the red-green refactor technique. These 3 tiny steps are the core of test-driven development. At the red step, you design the externally observable behavior of the system under test. At the green step, which is the most trivial step, you just write enough code to pass the test. It doesn't matter if the code you write is not clean enough at this point, right? You should just make the test pass, or switch the green state in another word. Switching to the green step shouldn't take too much time. At the refactor step, you improve the interior design of the system under test as opposed to the red step, at which you focus on the exterior design of the system under test. So you shouldn't start writing the next test without considering the interior design of the system under test. There are lots of patterns you can use for refactoring systems under test, but they are outside of the scope of this course, however. Well, congratulations! And we are at the end of the second chapter now of the test-driven development course. And now you know why test-driven development is super essential. You can create a new XUnit project and follow the red-green refactor process to write a test. And in the next chapter, you will learn to discover new scenarios and improve the trustworthiness of your test by parameterizing them. So definitely stay tuned and see you in the next chapter just in a second. Alright, we now have reached the end of the first 2 chapters. If you like the course so far and you really want to dive deep into TDD with parameterized tests, red-green refactoring, and building a test suite for real-world projects, you should continue with the rest of this course. You can directly continue for free if you sign up for our all-access subscription, because it contains a free trial period. You'll get access to the complete TDD course, all of our other courses, and even all future ones too. We highly recommend to finish this course first then, and afterwards start the ASP.NET Core course, which is also part of the Access Pass for sure. Now if you like this free TDD YouTube video, give us a thumb up and subscribe to our channel so that you no longer miss any free programming courses. Now it's your turn, sign up for the All Access Pass, and I will see you in chapter 3 of this course right over there.